Welcome, everyone, for my talk about Eval-Driven Development. My name is Urs Peter. I'm a senior software engineer, as you can see with my many gray hair, who still tries to be as much as possible with my hands in the dirt. I don't know if agentic programming is hands in the dirt, but I still try to be in that corner. I'm a passionate trainer helping Kotlin developers actually reach their next stage, and nowadays also with AI-assisted or agentic coding. I'm a certified Kotlin trainer, and the latest training I've created is about agentic applications. How can you create on a GVM agentic applications? I'm also a conference speaker and co-organizer of Kotlin Dev Day. That's a conference which takes place in the Netherlands, Amsterdam, and also very active in the Kotlin community. Enough about me. I'm quite curious about you. So on me the honor to have the lunch tip session. In order to not let you fall asleep, let's do also a questionnaire with you with some exercises. So all of you who has used an agent in any form, please stand up. Okay, this is really surprising. I would never have expected that. Of course I have, but it's good for your bloodstream, right? Okay, so now, wait, please keep on standing, This is not yet, we're not yet done. So, who of you has written your own agent? If you have, stay up, otherwise sit down. Okay, you see it's getting less and less. Okay, so the ones of you who have brought an agent to production, please keep on standing, the others sit down. Ooh, that's considerably less. Okay, and who of you has this agent smoothly running in production? Stay standing, otherwise sit down. Okay, so about 2 or 3, 5 people made it. Excellent, great, thanks. Cool, so, let's set the stage with a survey committed by LangChain, a big framework in the Python community, which asks companies if and whether they have agents running in production. As you can see, 57% said in 2025 that they have an agent running in production. So that's a remarkable number, and I guess by now, 2026, this number has increased even further. When we look at the challenges they had to overcome, then we clearly see that quality of outputs is the biggest struggle. Besides latency and response time, and of course, security and compliance, which to a certain degree is also related to quality of outputs. Which makes these kind of reports not very surprising, right? That's one from Gartner, even so it's almost Stone Age, June 2025, but it predicted that in 2027, 40% of all the agentic projects will fail. And when we look at the root causes, we see that besides having a good value proposition, controlling risks and operate agents at scale are the biggest challenges. Well, all these kind of facts and figures remind me of a story I heard in my youth, a nice fairy tale, which, by the way, is originated and created in Germany by Mr. Goethe, and it has the name The Sorcerer's Apprentice. In good German, der Zauberlehrling. And it goes like this. Well, you had a magic mighty sorcerer with an apprentice who was tasked with tedious, straining labor of carrying buckets up and forth. And on a day when the sorcerer was gone, the apprentice entered the cabinet of the sorcerer and found the magic hat the sorcerer left behind. And because this is very tempting, he tried it on, and all of a sudden he thought, okay, maybe I can now automate my work and my stuff. And that's what he did. So he wipe-coded an automated broom here, and things looked very, very, very appealing. Up to a point, as the story goes, things completely got out of hand, up to a point where it got life-threatening. Well, the good part of this story is there is a happy end, because eventually the sorcerer returns and reestablishes order. So this story has a lot of parallels with real situations, except for this very last part. If you have brought an agent in production and it completely fails, I wouldn't bet on the sorcerer coming in and rescue you. So this is purely fictional. Okay, so let's take a step back. How are we taming traditional applications? That shouldn't be very surprising, right? Our means to do that is testing. And for this, we have this testing pyramid. And when we just have all these green boxes ticking, we normally ship. And maybe in production, we also have some monitoring going on, and this often is good enough to ensure that the thing works as it's supposed to work. So if any one of you would just had the crazy, insane idea of saying, when it compiles, I ship it, probably you would end up very quickly at the hall of shame in your company. Whereas in the agentic age, it is not very uncommon just to build something together, test it a bit, and ship it, right? Which is very surprising. It actually takes us back to the beginning of software testing in the 50s, where the best way of testing your application was in production. That's the ultimate best test there is. Which is surprising, right? Because we have actually accumulated over the years a tremendous amount of knowledge how we should test applications. All of a sudden, if this agentic wave comes along, we kind of have forgotten about it. Well, that is not very surprising. Why? Because let's look at the nature of these systems. Traditional systems, they're so-called specification-driven. They are deterministic, which means we have a fixed set of code paths, for instance, a REST endpoint, a service, a database, and all these code paths we can test. For this we have coverage, we have property-based testing to ensure that all these paths are covered, and once we have them covered in tests, we also have some monitoring in production that these paths behave the way they should. Very good to go. However, agentic systems are behavior-driven. They are, to a very large part, probabilistic, which means that, indeed, they behave well most of the time, but not always. So this becomes painstakingly clear once we look at an architecture an agent normally is kind of facing. So here we have an application with an agent running, we have a prompt coming in, and then it does some interaction with an LLM. In this prompt, we have a system prompt we send along, which gives guidance to the LLM. And of course, this is human language, full of ambiguities. The LLM itself, of course, is by nature probabilistic. The same LLM will produce each time a different reply with the same input. And when you change versions, well, the spread is even larger. Then we always have some context involved in the conversation. We might have some conversational history. We might have loaded its skill, things like that, which also influence the way the thing behaves. Then we might do some RAG, retrieval augmented generation, which has a certain embedding model with certain qualities that is trained in a certain way. We might apply our way of chunking, might include metadata or not. Also, there are just a wide range of probabilities. Then tools. A list of tools. Does the LLM always choose the right one? Maybe it does, but does it then use the right input? We don't know. Same for MCP servers. So easy to kind of plug your agent full with capabilities. And MCP servers not only have tools, calls, but also resources, prompts, which can kind of broaden the spectrum even more. And you might also talk to another agent, and behind each of them, there is another avalanche of probabilistic possibilities available. And last but not least, we also, by the way, have a user. And a user has a mood, he has an intent, he has some knowledge, language skills. There we go. So an almost infinite amount of probabilities happening here. So in a nutshell, we can say that traditional systems have uncertainty at the edges, right? And uncertainty is in the way of concurrency, latency, networking, caching, and I think we kind of managed to deal with that. Whereas agentic systems have uncertainty at the very, very core. That's the big difference. Well, that's the kind of problem, right? You have George E.P. Box, a famous statistician of the 20th century. He made this sentence: models are all wrong, but they're also useful. So the ultimate goal is to have these models being useful while behaving most of the time. Okay, and for this, we have a tool available, which is Eval-Driven Development. That's the kind of magic wand we try to apply to make these models behave. And Eval-Driven Development basically is, from a conceptual point of view, the big shift from this deterministic way of thinking we normally measure with pass or fail, like a binary outcome, to see whether a system behaves correctly according to specification, to this probabilistic confidence score. because we cannot just capture the true and false, we can capture it with a degree of confidence in order to measure something fuzzy like quality. That's basically it from a conceptual point of view. So as such, the goals of Eval-Driven Development is that we try to control accuracy of our applications. And as such, we have to define measurable quality criteria, like the ones you see here, in order to meet the base expectations of users, of companies. And this is very important. How do we do this? We do this in a statistic way. So we have a lot of regression going on, and over time, this regression should kind of stabilize from a statistical point of view. And if we then just turn some cogs, it should ideally stay within bounds. If it doesn't, we also have areas for improvement to see how we can make it better. And of course, we also need to control costs and ideally some latency. So this all sounds very nice and dandy, could be a management talk, but of course, what we are interested in here, I assume, is how do you do this in practice? Okay? And for this, well, let's put on this hat and see whether we can make our simple demo application work within the bounds, stay controllable, applying EDD. So this is the demo application I have created. What you can do with this is talk to KotlinConf. So for instance, I could say, when and where does KotlinConf take place? And then ideally, it talks back. So this is a smart system. It thinks a lot. That's good. And you see, this is what it does pretty well. That's probably not very useful. What we can do on top of that is actually talk to the program. So I can ask whether there are still sessions, for instance, without AI. So if I want to have an AI detox, let's see if this is still possible. I'm interested in Kotlin backend applications without AI. What do you think? Is there something to find here? I'm still also surprised, curious. Apparently, there are still some sessions, so that is definitely good news. Okay, so far so good. How does this application look like? It's a very simple Spring AI application. Could be Koog, could be LangChain for chain, doesn't matter. So here I have my chat client controller. Then I have a system prompt saying, hey, you are a helpful assistant, and then some constraints. And probably the most important part which we have is basically the piece of the tools we are employing here. Oh, where is everything going? Okay, there we go. So here we have a variety of conference tools. So what I've did is I've ingested some general information about the venue. I can search sessions by means of a semantic search vectorized database. I took the program, I chunked it up, I put it in a vector store. So now you can query it the way agents expect data to be found. And then you also have some simple tools to create your own customized schedule, preferred sessions, add, remove them, and so on. So this is basically it. Okay, so let's move on. In order to bootstrap our EDD application, what we need to do more than with traditional application is to ask questions. Things like, what is actually the goal of this application? That might sound like a stupid question or evident one, but it's not. With traditional systems, all these code paths and functions are pretty clear. With an agent, it's not that clear. An agent can do quite a lot because it talks to an LLM. Right? So defining the goal is very important. Same for users and scenarios. Not only the good ones, but also, well, the rainy days. So that we can start building our so-called minimum viable evaluation loop, the MVE. And because such an agent has one interface which is just text, we also need to provide a lot of data before we can even start. And as such, we need to generate some ideally production-like data right in the beginning. And later on, of course, we will extend that with production data itself. So to do that, we define some user profiles, some scenarios, and then we let an LLM create some concrete prompt inputs. Humans ideally also verify those, you never know, in order to later actually extend this set with samples from production and also, of course, failures. Because the ultimate end goal is to create this so-called golden data set, that's the term they use, which is this curated set of, behavior, real-world behavior with corner cases and failure modes. Okay, so let's see how we could do this in practice. So in order to get there, we might use a Kotlin notebook. That's what you see here, where I define the different type of user profiles, first-time attendee, a backend developer, a front developer, and of course the goals this particular user would have. Then we also should come up with certain scenarios. That's what you see here, a first-time attendee looking for channel information, a developer looking for some program items, and a developer who wants to create his own schedule. And then we talk to an LLM, giving it some task, feeding it the user and the scenario, saying for each of these scenarios, create me a prompt. We execute this, and ta-da, we have a starting point to bootstrap our EDD workflow. Once, of course, we as a human have read through it and are kind of satisfied with it. All right, so now we can start evaluating. But how do you do this? You could do this by hand, of course. We can reinvent the wheel all the time. We could even, because nowadays, wipe code something. But ideally, it's good to rely on a framework, because many of these workflows are already incorporated in those workflows. And there are, of course, a lot of SaaS offerings and paid offerings. There are a variety of open source options. However, they all have an issue. They are all TypeScript or Python-based. And for my Kotlin heart, this is still hard to accept, right? So wouldn't it be nice if we had something for the JVM? There are some frameworks. Framework is a big word. Spring AI has some utilities to do that, but this is really more for a sanity check rather than a full-fledged eval workflow. However, there's good news. A few months from now, a guy started Dokimos, which is indeed a full-fledged EDD workflow that also has integrations for all the major JVM AI frameworks out there, LangChain, Spring AI, and Koog. And I personally had the honor to provide Kotlin support and Koog integration. And I also will be aligned with this project. It's interesting. So don't worry, I'm not going to tell you all the nitty-gritty details about Dokimos. Once you understand the workflow in Dokimos, you will also understand the workflow in any other tool. So it helps just to see conceptually what is going on, and we need something to demonstrate that. So Dokimos is definitely a good one for that. So how do you do a basic evaluation using Dokimos? This is what we do here. So the cool thing is that Dokimos runs as a JUnit test, right? It just nicely integrates with your Kotlin code base. And what you do is you define a so-called experiment with a data set and then examples. And the example of here is very basic, where is Kotlin conf held, and then we have an expected reply. Next, we have a task, which actually just calls your agent in any way you want. And then you have a variety of evaluators, and the one we're using here is a very basic one, which is a contains evaluator. So it checks whether my expected output is contained within the reply of the LLM. Then let's hit the road and see whether we get a pass here. Fingers crossed. I think by now, 2026, with all these smart LLMs, that should be fine, right? So we have a pass here. Okay, so the evals you have just seen right now, they were very basic, right? It contains. You might say, come on, you can't be serious. So it's now time to introduce you the eval pyramid, which I have invented. Why not? I haven't seen it before, so try invent pyramids. We like that from traditional testing. And the foundation of eval definitely are deterministic checks, because they're very cheap, they're very concrete. There's not a lot to kind of say whether we are happy with it or not. So the more we can have, the better. And things like schema validations, JSON payloads coming back from LLMs, tool calls, and so on are really suitable for these kind of tests. However, the test we just did with the contains doesn't really fall under deterministic check. This falls under ground truth checks. We provided a certain piece of context to an LLM, and we want to know whether the LLM has treated this context correctly. So we also have some deterministic, still deterministic, tests for ground truth. Well, With ground truth checks, you probably won't be able to provide sufficient guardrails for your agent. We need a more powerful tool for that. And this is where the LLM as judge pattern comes in. The way this works is as follows. So I have an EDD test engine, like Documos, which talks to an LLM, providing all these different context elements, which then also provides a reply. And then we have judges, which talk to other LLMs. Okay, so now you might say, wait a minute. You're now kind of fighting probability with probability? Yes, this is what we do, because we have nothing else. And we rely on statistics to still have a good level of confidence that it is working. So ideally, you would take a better LLM than the one you're using in production, if it's available, so the best one available. So probably it's smarter, right? That can give already a bit of confidence. What we do then is we provide the whole conversation to a judge alongside some additional data, like the reply we have expected, the ground truth we expect, the ground truth we have provided or we expect to be provided, quality criteria, tool traces, and so on. And then this whole thing is given to this LLM based on the prompt this particular judge has, and it replies always with the same kind of figures. A scored eval from 0 to 1, including some reasoning. Because if your score is very high or low, as a human you want to know why did you come to this conclusion. That might help. And here now comes the important part of it. Once you send this result to the EDD test engine, it needs to be stored somewhere in persistent storage to ensure that over time we still can see whether we stay within bounds or not. So we also turn to statistics to still have a vague idea and trust in that this still is okay-ish. Let's see this in action. So I have here more or less the same test like before, but now I have applied pirate speech to see how these things behave. So again, this is a case, an error case I would like to cover here. The rest is the same, I have my task. And now introduce this LLM judge evaluator which just has basically a client to an LLM with this criteria. And you see in this criteria we say it must be a business appropriate answer. And I guess when it replies with pirate speech, it's not that business appropriate, right? That's the idea. And of course, I can also, I need to provide a threshold for that. This is where I want to stay within, and I still can have, of course, other evaluators for the same interaction. Then also going to define a reporter, so my result is stored in some persistent storage. I have tracking over time. Then let's execute this whole thing, speed it up, and see whether the pirate survives the interaction, and apparently it does, right? So what we see here is, would you like me tell you? That's pirate speech, and that's not really business appropriate. So that's why probably it has 0.7. And now comes the important part, as said. Documos also provides a very basic UI, where we just see the example we have created here, and we can look at it, and we see this is the score that we just have had. And when we just look at other runs, we should see that the score is probably not always the same. Here it was 0.8, and it was maybe 0.75, but statistically, it stays more or less within this bound. And this should give us sufficient trust to continue. All right. So what we have checked now are kind of more tone or format kind of things of our interaction, or really hardcore deterministic checks. We probably need also something in between. So the question is, what can we test with evals? What we can test is basically everything we have a hook for. For instance, if I talk to a RAC database, then I have some input and I have some output. And for instance, I can check now whether the output the vector database gave me was contextually relevant for my input. And again, I would use an LLM judge for that. I also could provide output myself, that this is what I expect. And then you have something like a precision or recall evaluator, which is more of a deterministic eval. In the interaction with an LLM, we also have, for instance, context we provide, and we can see how did the LLM use this context. So did it hallucinate? So were there a portion of data added to it, or kind of inverse of hallucination? Was the LLM faithful to the context? Again, with a score. or we also can look at the whole interaction and see whether the task was completed. So these are the evals we can think of. And of course, if you're creative, you can come up with your own sets of evals. When it comes to tools, then it's foremost deterministic checks. Were the tools called I have expected or not? Which brings us actually to the next layer of our pyramid. So now we have also ground truth we can verify with LLM judges, or that's what is done with our contains eval. We just can check things like helpfulness, tone, reasoning, and so on. All right, so this is how advanced evals look like. So we have more or less the same example like at the beginning, but now we add a new example about the price. Let's see how LLMs can handle price. And then here we have our call to our agent. And in order to check whether the tools were called or not, we need to extract that information. So right now, here I have a request for the great people out here that create those agentic frameworks. They do an awesome job. Spring AI, Koog, LangChain, Ansel, Babel for the Java ecosystem. A nice thing, what I'm actually still missing, is a means to get a complete trace of what has happened in an interaction. There are ways to do that right now with metrics. We will see this in a minute. But it would be nice to have an API which just gives me that data, similar to a spy in traditional mocking, right? And it would even be a nice name, kind of an agent spy, right? Secret agent spy. I would like that. So that would definitely help in these eval frameworks, and probably also give an edge over more Python-based approaches. Okay, so I have now my expected of the tool calls that have taken place. Then I have a deterministic tool call evaluator, my faithfulness evaluator, the contrary, which is a hallucination evaluator, and eventually the contextual relevant one that checks whether the context was provided or retrieved by my rock store was relevant or not. Let's run this thing and look at the result. If it is able and capable of just displaying the right price. Ooh, apparently it's not. And to be honest, I'm still surprised how this is possible. But it is. LLMs keep surprising you. So you see the tool calls were fine. So it fetched the data from the right place, didn't invent it. The context was relevant regarding to the input, but it hallucinated, and also faithfulness was not really honored. When you have this case as a human, well, you need to figure out what went actually wrong. And then it helps to take a deep dive of an evaluator. In this particular case, the faithfulness judge, which can give you a good idea how these judges work. So the faithfulness judge, in this particular implementation, what it does is it takes the input context and dissects it into different truth statements, right? A lot of short sentences which define the truth for the context you have provided. Then it takes the reply and does the same, but then in the form of claims. The reply claims this, claims that, and so on. And then these things are compared to one another, so we can reach a verdict. That's what is happening here. And you see that it really states that the real price is 700, but the LM says it's 80.99, which is dangerous, right? Because people might pay 700, but not 8.99. And that was really what's happening. So this is the reply of the LLM. So it helps, of course, to have a kind of conceptual understanding how these judges work, so you better can kind of pinpoint what went wrong. Okay, sometimes it's not sufficient to only have a single interaction and verify that in detail. Sometimes you want to have a whole conversation. And Documents has a nice feature for that. It's called a user simulator. So I can define a user with certain mood, a certain intent, combine that with some conversation simulator. I can tell how the conversation needs to take place, some starting message, and so on. And then it will do its job, talk to the LLM till the conversation has reached the goal or not, depending on our conditions. Then the whole conversation will simply be passed to this particular judge. We can also include some quality criteria to that, and then get a feeling whether this conversation turned out to be correct or not. And of course, also here, the result is always the same. We get a scored eval and a reason for that. Let's see that in action. So here we have our user simulator. You see, I'm a certain persona, Kotlin developer, who wants to fill the schedule. This particular person is interested in these sessions, and the goal is indeed to fill the schedule. And if I have a trajectory simulator here, giving the max turns, that it doesn't go on infinitely, burning tokens like a lot. Initial message we can provide here, and also a programmatic stop condition if you want. That's, of course, optional. Then we have our trajectory evaluator, where we provide the criteria we want to apply in this conversation. So was the user satisfied, was the goal completed, and so on and so on. And then we kind of bootstrap the whole thing with evaluate or evaluate, and then the whole magic starts to run. The result we can print, but you also can have additional deterministic checks. For instance, what I would like to check is whether the sessions that were proposed had some overlap. That wouldn't be very smart, right? We cannot cut ourselves in half yet. So let's see how this conversation is taking place. Talking, talking, talking. Let the LLM do the talk, right? And eventually, we might see that this results in a result which is not expected. So we see here that the LLM indeed proposed overlapping sessions. And again, this is a good input to improve the quality of our chat app. All right, 2,000 years ago, in ancient Rome or Greece, people already found that this is an issue. Who is guarding the guards? Who is judging the judge? Well, I have good news for you. There is an answer for that, because in ancient times, it was hard to answer it. Now we have an answer. We'll see in a minute. So it's good to start your evals with off-the-shelf evaluators. That's fine. But probably the real world will demand more than that. So what you will have to do is you score your output with those judges, but then you, as a human, has to do the same. And then compare, right? Compare your results, your human-labeled results, with the one of the judge. And then it's you who is actually judging the judge and refining it. So this is a continuous loop which periodically you will have to refine your judges. So some human input is still needed. We are still needed. Wonderful. Okay, so let's recap the whole flow. We identified some goals, users, use cases, provided some test data, and then we started to create our EDD harness. And for this, we had these turn-based evals, we have these conversation-based evals. But we probably have a little bit forgotten about this, right? That was a recent message, a recent news item, where a hacker exploited 17 chatbots to commit serious crimes. And I assume that you probably don't want your company to be part of these 17 companies. Okay, so when we look at vulnerabilities of LLMs, the list literally is endless. Here is just a very simple category. I'm not going too much into that because that's really a topic for a separate talk. I just want to create and kind of augment your awareness that vulnerabilities and LLM is almost a synonym, right? So it really pays off to treat it like serious applications you build where you have some specialized team, a red team, to really challenge your application once you have a major release, or especially when you go live for the first time. There are some automated ways to do that. Prompt-foo, which is also such a tool, Python-based, TypeScript-based, but it does a decent job. And for now, the only thing I'm going to show you is actually the amount of vulnerabilities you can encounter, as said, to really sharpen your awareness. So what we do here is actually sort of doom scrolling of vulnerabilities. So what you see here are a nice collection of all the vulnerabilities found until now. Mythos is still in test. Probably the list will be extended once Mythos is live. So 20 seconds of doom scrolling, this is what you can expect when working with LLMs. So this is something you really have to take very, very serious. All right, so red teaming, security testing should also be at the very core. Okay, we've done our testing. It looks good, right? We have all these statistics pointing that we have solid confidence scores. Let's go live. And lean back. Well, that's probably not a very good idea, because that's another difference between traditional systems. You are not only a developer anymore, you are also getting a babysitter, right? So once the thing is in production, it needs to be continuously babysitted. And the way you do this is actually with just a lot of data. So you have to gather extensive amount of logging and store it somewhere. A good platform to do that is LangFuse. And well, what kind of data could we store? Let's brainstorm. Probably request responses would be helpful. Metadata, tokens, latency, tool calls, their input and outputs. Errors would also be helpful. And the good news is, even though that might sound kind of complex, actually all the GVM frameworks have built capabilities already in, which you can trigger with just a few environment variables or an export you configure somewhere. That's really awesome. So simply, at least in Spring AI, I provide some env variables with keys and URLs, and then ta-da, it just does its job by means of micrometer. Are we not missing something? Yes, we do. And this is, again, something very different than traditional systems. User feedback. Many times when you have some interaction and it goes totally wrong and the user is not able to notify you, you miss a huge opportunity. And of course, we want to give a user opportunity to complain. Not too often, of course, but still have the opportunity. So in our application, let's see if we can come up with that. So if I ask, for instance, I'm interested in backend frameworks that employ AI with the traditional frameworks, then I hopefully get a decent reply. And I'm kind of a picky person today, right now, and I see, hey, it proposed me sessions of yesterday. Come on, what a drama. I'm going to complain. And then it's very important to have this thumb down button where you just can type in what you have found, because this will really be a crucial part of how you can improve your agentic application. Okay, so far, so good. Babysitting is nice when it's automated, right? Then most of the stuff is done by you, and you probably get a call when something really serious happens. The same you would do, at least try to do as much as possible with agentic applications. So the more we can automate, the better. So errors, token usage, latency, a bit the same metrics like traditional systems. Where the manual part comes in is here. It's really important to periodically just pick some random samples as you as a human and figure out whether it went okay or not. That's really important to do. And of course, foremost, also employ the feedback. That's even more valuable information, because here you clearly know that something went wrong. The other ones you have to deduce it and hope you find this needle in the haystack. And feedback, of course, is more concrete. Because then, with this information, we can do a bit of TDD, convert the bad traces into failing tests. We can also extend our regression set, so to complete our golden data set, right, with real-world examples. And we can also use them to improve and align our judges. And if you're lucky, we might also find some systematic failures in the whole. So let's see how this would work, because babysitting is kind of annoying. I grew up with a brother that was 15 years younger, and I never really enjoyed it. So you want to kind of make this as convenient as possible. So what you see here is basically LangFuse. And the metrics you get with the Spring application is really impressive, right? You have here all the LM calls, all the replies. We have the tool calls up to the point where you do a vector search with the SQL applied in it. So very detailed traces. The same goes for our feedback we have just entered. So if you look at our text, hey, you judged me sessions in the past, it's just there. It's probably not very convenient to look as a human through this, so you will also have to build tooling to make that as simple as possible. So what I've created here is a so-called LLM feedback triager. Let's see how this looks like. So it also has a judge, an LLM connection, and then what it does for us, first of all, is classify a certain input, so that we do not have to do this ourselves. And the classification we get back are more or less these attributes here. a summary, failure mode, a severity, and so on. And then we simply can execute this thing, have a nice report generated, which we as humans can read quite easily. So that's what you see here, HTML output, which clearly states, so yeah, the user says the system recommends sessions in the past, nicely readable. We get some data from the trace itself, and in blue, this is what you see further below, you will get the classification the LLM did for us. And then we as a human can do the judgment. And if we then consider, okay, sessions in the past is a serious issue, we cannot allow that, then what you're going to do next basically is falling back to the TDD practice. First, create a failing test. That's what you do here. So again, another unit test we're going to add, an experiment with an example where we provide some input saying this is the time now, and a user wants to have one of these sessions, and then we provide a variety of evaluators. We still can evaluate whether the tools were called we expect them to be called. I even created a custom one, started session overlap, so that's very nice to kind of extend this framework with your domain-specific evals. And then when you run that, ideally, this particular test is supposed to fail. Fingers crossed that a test fails. That's what I not do very often, but well, that's then different today. And ideally, now we see that we have some overlapping session, which is really the case, as we see here. So this session was proposed twice. OK, so, and by that, we can actually complete our eval pyramid with the human view. So we are still at the top of the pyramid, just to make that clear, right? So for production traces, judge calibration, and high-risk cases, humans are still fully in the lead, or should be in the lead. So with that, we have seen that when you go live, logging, monitoring is more important than ever. You need to collect a really incredible amount of traces so that you can refine your evals on various levels. So regression, figure out systematic failures, and tune your judges, which then will serve to strengthen the EDD harness. And with that, you should be able to employ magic, but in a controlled way, so you as an apprentice doesn't end up in the chaos we have seen in the beginnings, so that the Zauberlehrling is not repeated. Well, should you now want to fix my application, there it is. You can clone it. It has still all the errors we have seen, and with kind of iterating over the loop, you might be able to make it really a decent piece of software. Thank you.